Hello, welcome. Thanks for joining me. Day 13 of Noah's bike build. Lots to pack in. Let's get started. I guess today falls into three distinct areas. Cutting away the engine mount so that in the future, if I have to take the carb float bowl off by dropping it down, it'll be accessible. Next part, finally sorting out the twin front brake, adjusting the cables plus more, and finally for today attaching the throttle cable and having a look at the carb. So that engine mount, days ago when I created the bottom engine mount, I cut a basic V shape in the mount to surround the carburetor float bowl. Worked great, did its job, but I decided to tip the bike on its side and have a look at removing the float bowl to make another instructional video for whenever my son and grandson become the new owners of this bike. I'd like them to have a thorough understanding of how it's created and how it can be maintained. On tipping the bike on its side, suppose I better say there's no fluids in the bike, so there's no problem. Tipping the bike on its side on my worktop, I could see that access to one of the cross-headed screws was slightly obstructed by the engine mount. So, as laborious as it may seem, stripping off the bottom plate and the engine mount from the frame, I did this because it's part of the evolution of the bike. It has to be usable and fun. Things like this are going to happen unless you have meticulous fuel filtration. You end up with dirt in the fuel and eventually in the carb, and these carbs have such tiny jets that it doesn't take much to block them up. And although we're not looking for optimum performance at this moment in time, I'd like it to start very easy, tick over and rev up, emulate that crackle sound of a racing two-stroke. So, frame stripped, engine mount removed, another piece hacked off the V slot, reassembled, and again pat on the back time. It all went together very easily. So with a little bit of maintenance, re-lubrication, these bolts are going to be really easy usable for future stripping and rebuilding. It's lovely to see nuts spin up to the point where you only have to tighten them, not fight with them all the way. So that was the carb sorted for now, or at least the access to the carb float bowl and the jets. The bike was stood vertical again and back on the paddock stand. Time to look at the disc brakes. It has twin front discs which are really over the top, but we'll go with the flow. It looks the bit. The cable operated. There's no hydraulics involved, and lots of memories came flooding back about leverage of brake arms. A brake arm, when it's going into a brake drum, and those of you that have had bikes with brake drums built into the wheel will know what I'm talking about, but suffice to say, the brake arm fits onto a shaft, and when you pull a lever, that brake arm rotates the shaft and applies the brake. And it's very important, in fact it's paramount, to understand that the brake arm should always operate efficiently round about the 90-degree angle. If it starts off more than 90 degrees and you apply the brake and it comes up to 90 degrees, great. That's the maximum braking efficiency. If it's sighted in such a way that it goes past 90 degrees, you're losing mechanical efficiency. More of that later when we look at the linkage on the twin disc brakes. It was just a simple case because these bikes have just been hastily assembled at the factory, forks and wheels and brakes, super quality but not adjusted, and that was my task today, to adjust them correctly. Blocked up the bike so I could rotate the front wheel. When you adjusting two brakes, it's important to know that both of the brakes are freeing when you release the brake lever, working equally, applying as equal pressure as possible, but then freeing again when you further release the brake. So having it raised up allowed me to rotate the wheel and see. One side of the brake had soldered nipple, and that was super. Once I'd adjusted the brake, tried it, spun the wheel, happy with it, locked everything up, that side was done. but the other side didn't have the solderless nipple. So back in the karting spares from long ago, I had the exact thing, a solderless nipple. So attaching that, it is just a case of the screw on the nipple biting into the side of the cable, but it does work, so I'm quite happy that it's safe. So that was the front brakes. 2 front brakes all working, stopping the wheel, coming free of the disc when released. Time to put the front wheel back down onto the worktop. A little bit precarious, balanced on the blocks. So back on the paddock stand and front wheel touching the worktop, the bike was stable again. Time to remove the bodywork, have a look at the carb and have a look at the throttle and throttle cable. The cable's just a simple length of Bowden cable with an outer and an inner, a soldered nipple on one end and a heftier nipple at the throttle end. Being familiar with this, I thought it was just a case of straightforward assembly. It turned out that the inner cable was too long. That meant one of the nipples had to be moved, and I chose to approach it by moving the carburetor end soldered nipple. It looked as if it was a tubular piece, but in actual fact it was just solder. So when I applied heat, it just melted. That meant I needed to find something suitable. I could have just built up with solder, but I thought I could do a bit better than that. Looking through my spares on the worktop, I saw that pop rivets have a top hat design that was crying out to fulfill the task. So tapping out the shaft from the pop rivet, cutting the pop rivet down to a suitable length, and then trying it in the relevant position on the carb slide. Let's just take a minute to familiarise ourselves with the internals of the carb. There's the carb top with adjustments for the cable. Inside, when we unscrew the carb top and lift it up out of the carb, we see that the slide has a slot in it so that it always goes in the right way. That's so that the carb slide cutaway faces the air intake. Within the carb slide we see a spring, and this holds everything together and returns the throttle to the closed position. With a racing bike, the last thing you want is the throttle to stick open. if anything, I want to create this bike so it's a tiny bit of slack when it's closed. So rather than it be absolutely instantaneous movement, I want to have to move the throttle a tiny bit, and this will help to ensure that the throttle always closes and stays closed when the bike's at rest. Back to soldering. The pop rivet top hat cut down to shape. I I tinned the Bowden cable just to see how it was going to take solder. Absolutely fine. And then I used this tinned area when I cut the end off the cable. This was the excess that I decided would create a cable the right length. That was an inner cable, the right length for throttle action. When cutting Bowden cable, don't try a hacksaw. Get yourself some pliers with a snip as part of the jaws. Position the cutters over the Bowden cable, grip it tightly, put it against something solid, then hit the side of your pliers, and that'll cleanly chop the cable. You don't want strands coming loose and causing problems. Strands splaying out are what causes throttles to stick open. Do everything in your power to create a smooth running cable. The tinned part of the cable kept all the strands together. I slid the pop rivet top hat in place, added solder, and then kept trying the cable and top hat in the throttle slide until I could get it to fit the cutaway that allowed it to seat. So that meant trimming off slightly on each side of the top hat shape, and I had a cable that worked, did the job. I also decided to take some still photos of a little trick I would say on assembly, because it can be a chore, but with the aid of these photos we can see how to assemble it all easily. And if I can do it with my eyesight, then any youngster would be able to easily. Cable on, couldn't resist trying it, turning the throttle, we see the inner cable go inside the outer cable, and the throttle slide lift and spring shut when the return is. So careful assembly back into the carb body, making sure the slot picked up the little pip on the side of the carb. Tighten the top of the carb finger tight, made sure the cable adjustment was correct. Down inside the cable and into the carburetor top, and filmed what I hope looks informative, that there's a tiny bit of play, and this is the tiny bit of play I want to see when a carb is set up for a youngster to ride a bike, so that the throttle is never hung up and open, causing the engine to rev. Last piece of the jigsaw is cable management. A smooth flowing cable can look unwieldy, but that's the key to having a smooth twist grip, a smooth throttle action. So again, taking photos of how I decided to run the cable. That's it for today. Engine mount sorted, brakes, front brakes that is, sorted, throttle cable sorted. Good progress. Thanks for joining me along the journey, day 13 of Noah's bike build. Join me again soon. Thanks for watching.